So now here the next set of question that we are tackling is another past exam question for summer 2009. The question is that the f of x that you have, a function f of x is 2x squared minus 12x plus 13, and have been given the domain is x between 0 and a, and probably later on we have to find the a value. Okay, now express f of x in this perfect squared form. So what we do is, once again, 2x squared minus 12x plus 3 plus 13 is being written in the format ax plus b the whole squared plus c. And now since you can open the bracket, and you'll notice that a is the coefficient of x squared, so a is straight away 2. So we get the expansion of 2x plus b the whole squared plus c. Now you open up the brackets, it'll be 2 times x squared plus 2bx plus b squared plus c. So that becomes 2x squared plus 4bx plus 2b squared plus c. And this equals to 2x squared minus 12x plus 13. Now, a is the coefficient of x squared that we already got. The constant term that we got is the coefficient of x is 4b here, and it's negative 12 here. So 4b equals to negative 12. That is nothing but negative 3. That gives us b as negative 3. Now, once we got the b as negative 3, what we can do is you can do 2b squared plus c, which is equals to 13. So 2 times negative 3 squared plus c equals to 13. That gives us 9 2s are 18. So 13 minus 18, which comes to be negative 5. So c is negative 5. So when you do the final value substitutions, my f of x now can be written as 2 x, and b was negative 3 here. So b, if I plug negative 3 in this, it'll be negative 3 squared and minus 5. Then they're asking state the value of a for which the f of x has a line of symmetry. So value of x for which the line of symmetry has a line of symmetry. So let us just first try to find out where's the vertex. Now vertex is by equating this big bracket to 0, that gives me, if I equate to 0, I get x minus 3 is 0. That gives us x is 3. Now since we got x as 3 here, this part becomes anyway 0, and my y coordinate of vertex is negative 5. So it's 3 comma negative 5. So vertex is at 3 comma negative 5. So what we're doing is now they have given that you're graphing it from 0 to a. So let's say if I graph this, which is 3 comma negative 5 is the vertex. So 3 is here and negative 5 is somewhere here. And your y-intercept is at 13, because if I plug x as 0 here, I get 13. So this up till here, half the graph I have got. Now, in order to have a line of symmetry for this graph, if I need to have a line of symmetry, my other half of the graph should look like something like this, because it should be exact half, and this is the line of symmetry, x equals to 3. So in this case, the largest a value that should go is, because this distance is 3, this distance must be 3 again from here, so that means this coordinate is 6. So the value of a for which it will have a line of symmetry, a should be 6. Now, this is very interesting. This is a logical way to look at the problem. Now, for this value, find the range of the function. Now you can see the range of the function is the possible y values, and that is nothing but, here when I look at, it is from here to here. Basically, this is the range, and that is nothing but, if you look at the range for this function, will be y should be between, basically here, y should be between negative 5 to 13. So negative 5 to 13, because this is, your y values are between these two values. So which is between negative 5 and this is 13. So the range is negative 5 to 13 for this. And coming to the final part, that for x greater than or equals to 4, explain why this function has an inverse. Now, when we just have done the graphing, you can clearly see, if I erase the entire part here, like left side of the graph, until here, the function was not 1-to-1. So my graph that you look at is, this is x more than 3. Now, obviously, when it is x more than 4, it will definitely will be one-to-one function. That's the reasoning you have to give, that because this is one-to-one function, hence it will have an inverse. And it passes the horizontal line test. Obtain an expression for inverse function. So we're going to use the perfect squared form, which we did, which is nothing but y equals to 2x minus 3 the whole squared negative 5. Interchange x with y. So x will be 2y minus 3 the whole squared minus 5. Make y the subject, which will be x plus 5 over 2 plus or minus here, and then 3. So since we are retaining the right side of vertex, our domain that we're going to take, out of plus minus will be a plus sign. So 3 plus root x plus 5 over 2 is the inverse function. This is the f inverse x for the given graph.